So it's Happy Plaid Day and Happy Don't Mess with School Loop this afternoon. All right. So you'll want calculators on the ready here. So we're doing this experiment. We have 21 subjects. That means they're people, not rats doing a maze. They're asked to solve some puzzles. Once they do it in a room with a floral scent, and once they do it in a room with no noticeable scent. Okay? So a pretty floral scent, some kind of perfume, but not overly perfumed, and then no real scent. You want to see if the pleasant scent increases the performance on the maze. And we want to, let's see, we want to throw this data into your calculator. And you don't need the subject's number in your calculator. You'll want their 2 times. Yeah, you can put the first one in list 1 and the second one in list 2. They're 2 times. These are seconds. Can't read these? Okay, hang on. Zoom 150%. Does that help? Okay. So you'll want to randomize your experiment so that half of the people, like let's say either 10 or 11 people, work in the scented room first, and then the no scented second, and then the other half work in the no scented first and the scented second, because just working a puzzle should increase your time the second time you do it, even if it's not the same puzzle. I don't know if you're actually building synapses, but you're building some intelligence on solving the type of puzzle that they would give. So we want to make sure we randomize the order in which you did these. We're going to practice doing this stuff in our calculators, I think. And there's my selection tool. That's not what I want. That's what I want. Back to a pen. Where's my pen? I still hear little button clickings going on. Since we're recording, maybe I should sing a little song while you guys are doing this. I could. It used to be whatever I was hearing on the radio into work. It got one morning it was Lady Gaga, and one morning it was Taylor Swift. But I didn't hear any music this morning. I kind of, since KQED is doing the fundraising, I don't always listen to NPR on the way in which case I'll end up hearing some music because I'll switch over to Alice when I can't get NPR.
So what did you hear this morning?
So I think they were just talking trash about somebody, as they often do. Alice in the morning. So Margaret, maybe you will be the next Sarah and Vinny. Yeah. You'd be no name. Or Human, or whatever his name is. Human. Human. It's his parents that made the mistake. Yeah. Okay, or how are we? So to check and see if you got your numbers right, give me a mean for list number 1 and a mean for list number 2. Ooh, I got 50.01 also for list number 1. We won't use yours. How about for list 2? 49.057 for the second list. Okay. So if you didn't get these two means, then for you, I'm just going to let you enter data into your calculator without it being in the list. So you'll remind me that we'll do that. You probably shouldn't do the next thing that we do. We want to know if people work faster in a pleasantly scented environment. So we're going to look at the difference in their times. And pleasantly scented may mean somebody's lunch, Margaret, in case you're thinking. Yeah. Okay. All right. All right. So if we want to decide whether people work better in these different environments, we're going to need to do a significance test. Okay? So step 1 of our significance test, I'm going to get a different pen here, I think, marker. Step 1, what do we do?
I forgot.
Okay. So our parameter in the population. Okay. So, ooh, that is too thick. Oh, okay. So our mu is going to be the mean difference in times to solve a puzzle in a scented room. Here we go. In a scented room and an unscented room. Okay, so now when I have two sets of data, I kind of like to analyze it before I go too far. I can't stand that pen. Okay. Okay, so if I took the time that it took them in the scented room and I subtracted the time that it took them in the unscented room, and I wanted to know if people worked faster in the scented environment, I'd be looking for a difference that was greater than 0 or less than 0. All right, so let's see. If we took the scented and we subtracted their unscented times, if we scored better in a scented room, we'd want that difference to be greater than 0. So I always like to figure that out first. So we want to do scented minus unscented, and we would like that to be greater than 0. So this is kind of a little aside. So in talking about my parameter, I'll say we're doing scented minus unscented. But I always like to think of the sign I'm looking for when I'm writing this out. Okay? So my step 1 also contains my null hypothesis and my alternative hypothesis. And my null hypothesis is going to be the mean scented minus unscented. I'll write it like that. Is going to be 0. We don't know how to do two completely different tests,